And this talk is really trying to steer some people away from the problems that I keep seeing in their use of aggregations. So what was surprising to me when I first joined Elasticsearch was just how many people were using us for logging type scenarios. So, I come from a background of working on Lucene and unstructured and free text, and what I found is a lot of people have taken us to heart in trying to deal with the fire hoses of logging data that machine-generated data throws at them every day. And some of the things that they were asking as questions of Elasticsearch were really hard to answer. And we're going to walk through examples of that. So this talk, the subtext of this is when aggregations don't cut it. So Alan presented what aggregations can do for us, and they can do some fantastic things. But there's certain questions that you can ask that are really difficult. And this is a typical scenario that we have for the sort of logging use case. We have users who have an ongoing fire hose of data coming at us thick and fast all the time, being generated by all these web servers, application servers, databases, all these logging sources. One of the things that we've just acquired is another one, actually. We don't just take things from log files anymore. We've just acquired a company that actually take it off the wire. So they'll inspect stuff on the wire, and they can decode the packets and figure out how many MySQL requests are being made per hour and all that sort of stuff. So we've got ever more sources of information coming at us thick and fast. And the coping strategy that we've evolved over the years is to organize this stuff into time-based indices. Somebody will create an index per day, and the sort of fading nature of the indexes in this diagram sort of indicate the fact that we can age content. So we can shift it off onto older hardware which doesn't have SSDs and spinning media. And then eventually we can delete it, or maybe back it up off into an HDFS system. So eventually the data sort of fades away in time. And this is kind of the coping strategy that people have today. But some of the questions you have when you have logging records are really, really hard to answer. So the toughest question I got asked wasn't some kind of complex geo query with time dimensions and everything else. It was just a very simple one. I want one number, which is on average, how long do my customers spend on my website? And if you try and do that using log records, it's actually very hard. So what we have to do is for each and every unique session ID on our website, piece together the first log record and the last log record and subtract the timestamps. And then that gives us the duration of how long somebody was on our website. But we've got lots and lots and lots of users, and that's why I've drawn it here as lots and lots of bubbles here. And maybe part of the reason why some people run into situations of running out of memory is because some of the questions they ask actually involve a lot of interim state. There's one answer that comes out at the end of it, a single number, but an awful lot of thrashing around in the interim. So I've distilled this down into a little recipe, which is how to cripple Elasticsearch with what I call a bucket explosion. So step one in the recipe is to ask us a question about values that need to be derived from multiple documents. So we're not testing properties of a single weblog record. We're not doing something like what's the most popular browser on my website, because that's just simple. Every single document has got the information you need. The referrer, or sorry, the user agent. You're asking a question about something which is a duration, a web session duration. And the answer to that is involved in looking at multiple records and subtracting timestamps from each of them. So the next thing is, how do we join these multiple records together? Well, if the key that you're using that they have in common is a high cardinality field, then we've got to piece together, in this example here, something like IP address. You're going to have many unique IP addresses hitting your site. So you would have many unique values here, many keys that need to be joined together. So that's another ingredient to this, this recipe here. And you make it extra hard for us if you do the default thing that most people do, which is just to spray gun their content across all of the shards that make up an index. So we said, for example, we have a default of 5 shards per index. If you take every weblog record and just spray gun it across one of those 5 shards somewhat randomly, it makes it even harder for us to piece together just how long each web session took on our website. So this I call the Coke and Mentos recipe. It's an explosive combination of seemingly simple ingredients, but the effects are kind of pretty catastrophic. So the solution is not to try and do everything at the very last minute, the point where somebody asks the question, what's the average duration of a web sessions on my website? What I am advocating here is you adopt a pay-as-you-go model to the cost of this computation. I don't think this is anything that's peculiar to Elasticsearch, this problem. This information that we were looking for, you have to pay a computational cost to derive. And if you defer that cost until the very end, the time when somebody does a query, we've just got too much work to do. So what I'm proposing is that we adopt a pay-as-you-go model, and there are actually some benefits to that. So how do we implement this pay-as-you-go model? So I'm not proposing anything particularly radical here. You continue to take your usual stream of events and you put them in your usual set of indexes. You'll notice here I've coloured the events here with a red dot and a blue dot. So what these represent are the activities of a red user and the activities of a blue user. We're really interested in users, and a lot of people are interested in the behaviours of people. Unfortunately, the way information arrives in our systems, it doesn't all arrive conveniently packaged with a neat little summary of every individual. We have to reorganise this data to do analytics on it. So the proposal is periodically, and that might be every day, every month, every week, every hour, every minute, up to you. Take an extract of the most recent events that have landed in this system, sorted by your user ID or your entity ID. In this case, it would be a session ID, for example, a web session ID. So take the latest little burst of activity that's happened on your website, sorted by entity ID and time, and then update. I've drawn here some little profile booklets. These are just a normal Elasticsearch document, but if you like, it's a little summary of each user, so red user and blue user. So we're taking two events that belong to the red user and sending them off to one shard over there, which is looking after red user's profile, and the other document is going over to the left-hand shard there, which is blue user. And we're using a little Groovy script to take this latest batch of events and update the profile of this user. And these Groovy scripts can get quite creative about what you choose to keep about each individual. They could, for example, just keep appending events into an endless list of things. That might not be the best way of doing things. They could be quite selective and creative about how they summarize the behavior of a user over time. So what I want to do is show you some examples of these sorts of Groovy scripts and what sort of insights we can get from the data. Is everybody okay with this so far? All right. So if I build a profile for these entities, get away from looking at log records, but actually consolidate them into entities like web sessions or users and so on, what sort of questions can I ask that I couldn't previously? Well, number one is I can ask the question, how long on average do customers spend on my website? Because for each and every user, I can keep a record of how long they've been active on my website. It's a simple data arithmetic. So that's a property of every single user profile now, how long they've been on my website. Another property that I could derive is which users look to be behaving like bots. Has anybody got any ideas how you might derive that piece of information?
Between clicks.
Times between clicks, so regular intervals between clicks. Maybe the fact that they only ever ask for HTML, they never ask for the CSS, the JavaScript, the images. Because they're not interested in that, they're just scraping the HTML. There's a number of different things that would indicate the behavior of a bot, which you wouldn't get from looking at individual log records, but if you were actually consolidating lots of activity around each user, you could have a very simple rule that figures out if somebody's a bot or not. What is the most common exit page on my website? That's another hard question to ask, because you've got to look at each user individually and say, what was the last thing they looked at? It's a very simple thing to do if you actually use a script to actually just record the last thing that somebody looked at each time. If we have bank accounts and we're looking at transactions, does this new payment match the typical spending behavior of bank account X? So my colleague Colin, who would have been here tonight if he wasn't ill, just had an alert because his credit card was being used in the US and withdrawing money, and yet he was in London spending money. So you can't get that far, and use that credit card in that distance. So that might be something you can quite easily pick out. The example that I'm going to walk through now is what do users who bought product X also tend to buy? So if you know the buying patterns of each and every user, you can start to reason about some of this stuff. So recommendations, which buyers employ shills, or which buyers behave like shills, and who are they promoting? So a shill being somebody who's giving fake feedback in a marketplace, for example. So I've got a real data set and some real scripts from Amazon where there's this sort of behavior going on, and you can use the scripts to actually pick apart what's going on there. Car data. I did some stuff with all of the MOT records in the UK. I wanted to know what types of cars were being driven long distances after failing roadworthiness tests. So again, you got to look at multiple event records, multiple tests. What was the date on which the car failed a test, and when was the next time it presented itself and actually passed the test? All the time in between is driving around in a failed state. So let's have a look at that first use case. The user who asked me about user durations on websites. It was the company G-Forces, and they actually do this for a living. They work for automotive retailers and manufacturers, and they analyze behaviors on websites and present that back as analytics. So they're in the business of doing this stuff for a living. And they summarize lots of behaviors, unique numbers of visitors per month, engagement. This is this thing about how long are people spending on my website. Somebody just invested a whole buttload of money into redesigning the website. They want to know if it had a positive effect or not. It's just stuff people want to know. And these were the people who were suffering these scaling issues. They were running out of memory, or things were just taking very long, trying to do computation on raw log records. And it was just the wrong way of approaching the problem. So they adopted the architecture that I outlined on the previous slides and reoriented things around users. So they ended up boiling 150 million events down to just 26 million user sessions. And they used to, on their event-centric index with the log records, their queries would take 25 seconds. And frankly, they were lucky it didn't actually just fall over in a big heap. They were trying to do so much. The equivalent aggregations that they're doing now, what's the average duration? It's now less than 50 milliseconds on the same reoriented data. They've got much simpler queries as well, just for the things like where are people exiting the website? What's the last thing they look at before they go away? It's a very simple query to run that. So the example where I've got some code and data that you can play along with, there's the URL here, there's some anonymized Amazon data, is about marketplace reviews. So these are reviews of sellers in the marketplace in Amazon. So Amazon aren't the only people selling stuff on Amazon.com. There's a lot of independent sellers, and they get reviews. And I was very interested in the rating system for some of the sellers. I've been a very unlucky buyer. I don't tend to buy many things in marketplaces. I've only bought a couple of things, and both times I got ripped off, and I couldn't, for the life of me, believe that this happened. I would be that unlucky, because I bought from 5-star sellers, and I bought what was supposed to be a brand new camera battery, and when it arrived, it was clearly secondhand and it wouldn't work. So I thought, how on earth was this seller getting 5-star reviews if he's routinely knocking out secondhand goods as brand new? So I started downloading all the data from their API, and it's all bundled up in this stuff here. So I've put it into a reviews.csv file here. I've got a little script to load it into an event-centric index, so it's just one record per review. And it's got the sort of stuff you would expect in there, a rating 1 to 5, who the seller was, who the reviewer was, and the date. So that's all the information that we've got in that review CSV. I've then got this script that then reorients the data and creates a little profile per reviewer. And this Groovy script here, I'll walk you through what it does, but it tries to characterize each reviewer, and it gives them a little character, which is where things start to get interesting. So the Groovy script we run has got the following kind of structure. The first line is where Elasticsearch says, here's a context, and basically this is everything that we knew previously about reviewer number 27 or whatever it is. So we get given the historical state of a reviewer, and ctx._source is a bit verbose, so I've just put it in a temporary variable there called doc. The next thing we do is, if this is a brand new reviewer, we've never seen this guy before, then I just initialize some variables here. So Elasticsearch tells us this is a create operation. We've never seen this reviewer before. We then have a main sort of for loop here, which is where I take the latest batch of behaviors that have been recorded against this reviewer, and I attach them into some existing state about that reviewer. So in this case, I'm just doing a very simple thing. I'm just adding 1 to the total number of reviews that that person's ever done. The more insightful stuff comes from some profile logic that I've got down the bottom here. And this is where I've started to get creative about how I'm going to characterize each reviewer. So the scheme I came up with is I'm going to call a reviewer a newbie if all he's ever done is less than 5 reviews in the marketplace. So you don't graduate from being a newbie to something else until you've made at least 5 reviews. If you've made more than 5 reviews, and they've all been negative, and they've all been to the same seller, why would you do that? Why would you keep going back to the same seller saying, you're terrible, you're terrible, you're terrible? So I call that guy a hater. Any idea why somebody might do that?
Competition.
Competitor, yeah. So he's actually trying to downplay the ranking of a seller in the marketplace. I didn't find any haters in the data, but you've got to admit it'd be an interesting one to find, right? I did find some other people, which I call just unlucky. Every review they've ever done, they've had a terrible time with Amazon, and it's been with a whole array of different sellers, probably like my own behavior. So the suggestion there is probably that Amazon ought to reach out and give that guy a hug, or just they're going to lose him as a customer. He's routinely having bad experiences in the marketplace. Right? So that's another interesting one you want to find. The one that I was interested in is the fanboy. This is the account, the reviewer that keeps coming back to the same seller and keeps saying, "You're great, 5 stars, great, 5 stars," and he keeps never any other sellers, just the one seller. "You're great, you're great." This isn't indicative of fraud on its own, but when you start to look at clusters of fanboys, that's when it starts to get interesting. This is how you would find clusters of fanboys, which sellers are employing armies of fanboys. So my query is, find me all the reviewers who I've characterized as being a fanboy. And I'm using an anomaly detection thing that's part of the toolkit we have here called significant terms, which it says tune in to the sellers that are being reviewed who have a high correlation with fanboys. And I found there's a seller up here. So just to describe this little chart we've got here, a visualization of this stuff, there's a little circle way up there. He's managed to capture 70% of the fanboy population, and yet on the x-axis, he's a minnow. He's got a tiny fraction of all the people who are actually running around buying things in the marketplace, and yet he's got 70% of the fanboy market. So that's a kind of very iffy-looking seller. He's way off the charts when it comes to his share of fanboys. The mix is all wrong, and this clearly shows this stuff. If I look at the actual fanboy accounts associated with seller number 187, you'll notice a sort of strange vertical alignment of all these things. This is time. So these are years. This is 2 years. But if you zoom in on this timeline here, within 5 minutes of each other, these 10 accounts always check in within 5 minutes of each other, make a 5-star review, and then maybe 2 weeks or a month or a week later, they'll all come back within 5 minutes of each other again and say, seller number 187, he's really good. And it uses different language every time, and he's been quite clever about trying to hide his tracks. But each of these reviewers has a characteristic that I only spot when I look across multiple log records of their behavior. So that's what I'm trying to steer people towards, is lift your gaze up away from the low detail log records and start trying to assemble them into sort of higher value units of information like user behavior profiles. So similar thing with the car roadworthiness tests. This is for the benefit of all the people who aren't from England and know what an MOT is. Yes, we have to have a roadworthiness test in the UK that checks the vehicle is roadworthy. It's illegal to drive a car that's failed an MOT unless you're taking it home to get it fixed or whatever. Another piece of trivia, taxis and other forms of public transport don't get tested annually, they get tested every 6 months. So that's the data that we're looking at. You can download it all, there's a lot of it, 37 million records, I think, in this data set. And again, did the same thing, take all of the individual events, or in this case the tests, put them into an event-centric index, and then reorient them again, run this script to kind of sort them by entity ID and then put them into little car profiles. So I build a profile for each car. So what attributes can you derive about a car's behavior over time? Well, actually quite a lot when you get into it. There's 3 test events here. The red ones are where the guy's failed the test, the car's failed the test, and the green one is where he passes. So you would normally expect to either find a green or a red, then green. So somebody will fail a test and then they'll come back after they fixed it. That'll be the typical kind of thing that goes on. Between each one of these records, as they arrive, I can derive additional attributes on a car. So one of the attributes I can derive between event 1 and event 2 is a stupid reading flag. So if you come back 2 days after failing a test and we check the mileometer again, if you've done 100,000 miles in 2 days, that's not physically possible. And yet this exists in the data. You find a lot of these. When you look at it and you do an edit distance comparison between the 2 mileometer readings, you'll find that there's like 1 digit that's been missed or something like that. So we can actually find the bad readings. Much like the fanboy profiling, we could perhaps do some analytics to say which test centers are routinely getting that sort of stuff wrong. So we need to send some glasses over to the guy who's doing the mileometer reading. The distance between the first failure and the subsequent pass is how long it took you to get your car fixed, the number of days. Mileometer readings should only go up and to the right over time. So if you go down from test 2 to test 3, then you might have been rewinding your mileometer. That's going to be an interesting thing that people might get up to. The gap on the vertical axis between the first fail, and the pass is how many miles you were driving around with your car in a failed state, which you shouldn't be doing, right? You should drive it home, you should take it to a garage to get fixed maybe, but you shouldn't just be kind of driving around all the time with a failed car. So we've got 3, 4 brand new attributes there that we can store on cars, and then we can do some analysis on that. Here's an example of a piece of analysis into failed vehicles and how long people are driving them and how far they get driving them. So not surprisingly, it goes from 0 to 365. So some people take 365 days to actually get their car fixed. And not surprisingly, the longer you spend getting your car fixed, the more miles you've actually driven. That makes sense, right? Because you had more time to do it, so clearly there's a correlation. What's weird is the big spike right in the middle there. Why is there an unexpected peak in miles driven with failure around 6 months? Has anybody got any ideas on why that would be?
The taxis. Another transport.
Hold on. Yeah, use the taxis. If you actually drill in on that particular spike and say again the significant terms, tell me what stands out as uncommonly common, unusually overly represented in that particular piece of the data. These are the makes and the models that are unusually highly represented in that spike. So Volkswagen, Chiron, STDI, whatever it is, that's like one of these 7-seater things that people routinely use as taxis. All these actually have the word taxi in the name, but that's a bit of a giveaway. So yeah, it's the taxi drivers. And ironically, this government initiative that said we should test vehicles twice a year because it makes them safer. Well, maybe what's going on is the taxi drivers are failing here, and then they're figuring, screw it, I've got another test coming in 6 months, I'll just carry on driving. So ironically, it's actually potentially making it less safe than if they just tested them every year. But again, you don't spot this if you just look at individual log records. You glue the things together, you do some kind of little calculations, they're fairly simple ones, but you've got some higher value things for doing analytics on them. users as the center of summaries and analytics, we and our collective little behaviors that we all have are actually fantastically insightful about connections between things in the real world, products and tastes and interests. So our own little cloud of data that we have around us, if we stack them all up and put them in a big system somewhere, we can actually do things like recommendation engines. So Movie Lens is an example of a data set, which is a user-centric, person-centric, entity-centric index. So it hasn't been built using the architecture I described. It was kind of pre-built. But the advantage of what you can do using one Elasticsearch document per user with a list of their behaviors, in this case movie ratings, is you can plot all sorts of interesting things. Here I'm plotting a random selection of these users and their movie tastes against everybody else in the world. If I take a random sample, actually 25% of them will like Shawshank Redemption. 25% of all people like Shawshank Redemption. 0.1% of all people in the general population will like the movie, you know, Eraserhead or something. And 0.1% of all people in the random sample will like Eraserhead. Everything is in its normal proportions. If you take a random sample of stuff, frankly, it would be weird if one of these things deviated from what you see as a normal distribution. So this just shows the fact that if you take a random sample of stuff, everything is where it should be. It lines up on this line of, you know, a lot of people like Shawshank, less people like Eraserhead. Feel good movie, feel bad movie, you know, that's what we would expect. If we don't take a random sample of people, if we take a very specific sample of people, in this case, all the people who happen to like the movie Blades of Glory, then we see here, using that significant terms algorithm, these dots shift wildly away from that normal line of expectation. What we see, for example, is Talladega Nights was shot up to, it's there, you know, 25% of all the people who like Blades of Glory like Talladega Nights. Well, that's unusual, that's uncommonly common, because only 1% of all people in the world like Talladega Nights. So taking these user-centric documents and analyzing and doing these forms of analytics on them, we can start to reason about the behaviors and connections in data, because we are the glue that kind of makes these connections all the time through our own tastes and our own interests. So some of the conclusions about building entity-centric indexes. It actually makes your queries an awful lot simpler. You know, what's the most common exit page on my website? That's a really easy one now. We can get much more deeper insights into what's going on in our data and things like fraud or marketing opportunities or recommendations if we actually fuse all the data around these individuals. We don't necessarily have to fuse it around users. We can actually roll data up into other forms of summary. So we can actually roll, you know, daily or weekly indexes up into daily summaries or weekly summaries or monthly summaries. So what we're actually consolidating and summarizing the data into doesn't have to be an entity. It could be a concept like a time period. You can use the existing Elasticsearch APIs. The scripts that I provided in that link are an example of how to do it. But equally, you could be going off and doing some churning elsewhere using, I don't know, Hadoop or whatever, you know, batch jobs you want to actually create these objects. I don't really care how you make them, but I'm just trying to steer people towards building these entity-centric indexes one way or another. If you are going to fuse data, avoid fat entities. There's always going to be people who have unusually high volumes of behavior. So we have, you know, there's people on Tinder, for example, who just have 50 million swipes or whatever it is, if that resonates with any of you. We had a bank who were creating entity-centric indexes around bank accounts, and they were remembering every single transaction each bank account had done. And some bank accounts ended up being gigabytes in size because they never forgot anything. They just kept adding to this enormous pile of transactions inside this bank account. So have some policy for not just overloading these things. They end up growing to supermassive entities and actually start to throw some stuff away. So use forgetful collections. Don't use an endlessly growing array of stuff. Use priority queues, circular buffers, things like hyperloglog. There are various different technologies now for summarizing data without actually having to remember every single data point. Avoid pointless updates. If you get a stream of events, and it may be a flurry of activity on a website, I load a web page and then there's a whole bunch of things that happen as a result, you can thin these out. Or if the stuff that you're seeing that's coming from me is just, Mark's bought milk again. He's always buying milk. He bought another bottle of milk. Do I need to update my profile as a result of that? No. Save yourself the cost of a write. And in your scripts, you can have some business logic that just says, I don't want to update this. So you tell Elasticsearch context.op equals none. That just basically tells us there's nothing to write here. Don't bother updating Mark's profile. Consider options for reducing event volumes. So you could potentially use aggregations, the aggregations framework that Alan was talking about. Rather than asking for lots of low-level detailed records from your log store, you could actually use aggregations to summarize a lot of stuff and then apply a much simpler update. Or you could, for example, be thinning out the events in that Python script that I described. It was kind of the glue that was pulling stuff from one index to another. Equally, you could parallelize the pull of event information. So we end up sticking stuff in a sharded index over here, which is your entity store. And we've got a sharded index over here, which is your event store. And right now, my script is actually pulling it all through one central node. So pulling from lots of different servers into a single script and then fanning it out again. Actually, that's probably better parallelized if you wrote your software in such a way that it actually was more parallelized in the way it streamed data. Oh yeah, of course, you don't have to do this as a big bang approach. You can just top up your profiles as time goes on, doing an incremental update. So you just simply do a query to your log store saying, get me all the things that changed since the last time I updated my profiles. So you can do an incremental update. If you're going to be doing these sorts of things, you have to implement some policies for making sure that these updates are being transferred correctly. So if you get a failure on your entity-centric store because it's busy doing stuff or it's gone down for some reason, then obviously you would have to kind of implement your own policies for managing any failures in the transfer of that stuff. And you also might want to think about retiring old entities that haven't updated themselves in quite a while. Then perhaps site visitors that just haven't come back and you're not really interested in tracking them anymore. So that's pretty much it. And the hope is that people who are running into problems doing analytics on raw log records will start to think about maybe implementing these entity-centric models. There's another customer, there's a gaming company who are building user profiles rather than looking at the raw log records just to overcome these sorts of issues. So that's it. Questions? Stunned silence. Does anybody think they got that problem? Any of the Elasticsearch users? I'm solving problems no one has. Because aggregations work so great, you never needed this in the first place. If you're doing stuff at scale, you will run into some of these issues when you're trying to look at the behaviors of lots and lots of people and you're just trying to do it from raw log records. But there's gold in this data, and if you fuse it together and be creative about how you summarize behaviors of users, there's all sorts of opportunities to use recommendation engines or fraud detection or whatever. It's all about kind of joining up the dots. Okay.